Okay, I think we should start. He's Andrea Valenza. He's a PhD student in cybersecurity, and today he's gonna present us something about CTF and hacking and security related stuff about CTF in the wild. So,
okay. Thank you, Luca. So thank you everyone for being here. As Luca said, I'll be talking about quick assumptions on security countermeasures and how to face them in the real world, and which is how I learned stop worrying and love the CTFs or anything like that. All right. So what's a CTF? CTF is a capture the flag, which is a cybersecurity event in which security participant can face security challenges, and there are many types of CTFs. We have Jeopardy, which is a collection of security-related puzzles. Then we have a red team, in which a team of participants can try and break the security of a system, of a given system, and try to extract information, which is called flag. And then we have red team versus blue team, and one of these two sides can be automated. And if we are the red team, we have to get the flag from the blue team, protect the systems. And if we are the blue team, we have to protect the systems from the red team. All right, so we will focus on Jeopardy CTF challenges and what comes from that. So we have security-related puzzles, as we said, and they are often based on real-life vulnerabilities. So we find often when security professionals try and create a Jeopardy CTF challenge, they go for real-world vulnerabilities that they found in their job or they found online, and then they try to make a puzzle out of that. For example, we can bypass a login form with something clever. Then we have corner case or unusual configuration of systems, which causes some security issues. And they are often hard to solve because of a cognitive bias called the functional fixedness, which is a bias in which we automatically assume the function of an object. And this was explained by Dunker in the Dunker candle problem, in which participants were given a box of matches, a box of thumbtacks, and a candle, and they were asked to attach the candle to the wall and light it without letting it drip on the floor. And participants tried to attach the candle to the wall with the tacks. Then they tried to melt the candle and stick the wax to the floor, to the wall. But they often couldn't find the right solution, which was to put the candle in the tack box, and then attach the box to the wall. This is because the tacks were given in the box, and participants automatically assigned the function of the box to containing tacks. So they couldn't find another use for that particular object. And we will try to focus on that for security-related issues. So the CTFs may sound useless, but they are the most common way to deliver hands-on security training right now. And for example, Cyber Challenge, which is this one, Cyber Challenge 2018 is running right now as we speak on room 506, anyway, 50 something. Okay, so we will talk about weak security assumption on security countermeasures. And we will see how we often expect the countermeasure to behave in some way, but then we find that it doesn't work as magically as we think, and we need to account for that. So, first of all, real world. Sometimes I will talk about PHP, HTML, and web-related stuff. So we will start by saying for a real world analogy, which is the pin tumbler lock, which is the simple key lock. Okay, we have a pin tumbler lock, and our assumption is that we can open the door if and only if we have the right key. If we don't have the right key, we can't open the door. Okay, and this is the high-level abstraction for the pin tumbler lock. If we dive into the reality of the pin tumbler lock, we know that it's made of many components, which are a chamber, a shell, pins, and stuff like that. And if we have the right key aligns all the pins, and the shell can rotate inside the, no, sorry, I don't remember the name. The yellow part can rotate inside the shell. So I don't remember the name in English, I'm sorry. And so if we have the wrong key, the pins don't let the shell rotate. All right, so how can we exploit it? The common lock picking technique. So we can rake the lock, or we can have other techniques. And this is the real world example. Okay. So we can move to the most common security countermeasures we find in web technologies, and we have security characters, special character sanitization, in which we talk about MySQL real escape string, MySQLi real escape string, which is the new library. Then we have blacklisting and whitelisting. So first of all, MySQLi real escape strings. So people think that MySQL real escape string will sanitize all MySQL special characters. So we think that we can give a parameter to a query, and if we have a special character for MySQL, it will be sanitized. But we can actually see from the manual that MySQL real escape string only sanitizes string terminators. Or actually, it sanitizes the null byte, then new line, and stuff like that. So we have a quote, double quote, and backslash, which are escaped to prevent SQL injection. And then we have more escapes, which are for not making the log file unreadable. So this is the reality of the function. So this function works, but only in a given environment. For example, if we have a simple SQL injection, we have, for example, something, quote, or 1 equals 1, so a tautology. And it works because it blocks string terminators, and we can't escape the string. But if, for example, we inject this payload in an integer field, we don't need quotes, we don't need string terminators, so we can bypass it. So we can do this, and MySQL real escape string is ineffective in this case. So this is the first example. Then we can move to blacklisting. So blacklisting means if we try, for example, we try to inject a cross-site scripting payload. We try to inject JavaScript into an HTML page. So we usually need some JavaScript enclosed in script tags. So those HTML tags, if you are familiar with that. Okay, so we can try and use something like this. We can try and inject payload instead of for example, our name. So this is a page that displays our name, and we try to inject script alert 1 and close script. And this one should make a pop-up with saying 1. Okay. So we can try and block this by using prep replace, which does Perl regular expression, which is script case insensitive, and then removes it, so it replaces it with an empty string. Okay, so the reality is script tags are not the only element in HTML that can contain JavaScript. We can use, for example, the on-click on something attribute on HTML tags. For example, we can use on mouse over, and then we use I use confirm here. It's the same. So we have alert, confirm, and prompt, which are all functions that display a pop-up to the user. All right. So if we try to exploit it, we can use this payload. So we can use another HTML tag like SVG, which is for vector graphics. And then we have onload, which triggers as soon as the element is rendered. And this one displays an alert. So we can have another exploit. This helps us bypassing the Chrome XSS auditor. So if you ever used Chrome, maybe you tried to perform some cross-site scripting, and if so it doesn't work, you have to go on Firefox or disable some security features. So you can, how does the cross-site scripting auditor work? So the auditor works on reflective cross-site scripting, which means I put some payload in the query string of the GET request, and then the payload is sent to the server and then sent back to the user and displayed on the page. So the cross-site scripting auditor tries to see if there's something that could be a cross-site scripting in the GET request, and then if he sees that in the page, in the loaded page, it disables that script. So we can trick the cross-site scripting auditor by injecting random, not quite random, but we inject the script word in the previous payload. So we have this payload, and we put script, the word script in there, so the auditor doesn't recognize it as a cross-site scripting payload. But then the server removes the script words, so it goes back to the user and it's triggered again. Okay, so the other problem is blacklisting is wrong by design, because we can put the script word in a text just by embedding the script word inside the script word. So if we say, for example, sc script RIPT, so the server removes the script word, and the script word again is reassembled and it pops on the page, on the user page. So this one is a fault by design, not by implementation. Okay, so we saw that sanitizing special characters doesn't work, blacklisting doesn't work. We can try whitelisting, which is I just let the desired form of payload pass. For example, emails. So a function that tries to validate and sanitize payloads by using whitelists is filter var in PHP. So we get filter var, the payload, for example, the variable email, and then we have some switch. For example, we can use a filter sanitize email, which sanitizes as an email format. And we often assume that emails are something at something else .it, com, org, something like that. So there's no way I can put something like ASD and or something like that. Okay, no way I can put it in a format which resembles an email. So a problem with this assumption is, in reality, the RFC 53 okay. Okay, no, sorry. Okay, the RFC for emails is quite different from what we usually see as an email. We can enclose special characters in double quotes, and then we can put, for example, it's a me, so we can put a quote in there, and we wouldn't expect it in a normal email. So we can do something like this, and this is validated as a valid sanitized as a valid email. But when we try to put it in a database, it triggers a SQL injection fault. Okay. Okay. So we saw that normal, simple security countermeasures are ineffective if we don't use them in the right way. But we can try and use them in the right way, and then we are fine. But there are advanced countermeasures which can be bypassed anyway if we use them in the wrong way. So we have context-aware sanitization, sandboxing functions, and sandboxing native functions for JavaScript. And we can try starting from context-aware sanitization. So we saw that pragmatch doesn't work against cross-site scripting, because we can try and make the payload bypass the the script payload can bypass our countermeasures. So we can try and use something like HTML special chars, which is the, let's say, the de facto function for cross-site scripting sanitization. And we can use, for example, the script tag. I don't know if you are familiar with the syntax. We have a script, and we have a minor and a major, and gets converted in ampersand, LT, column, and this. And this is fine. We can't inject HTML tags, but we can inject something like this, which looks useless. But if we put it in a HTML field, for example, in a value field like this, enclosed in quotes, we have something like ASD quote on load equals, and we can inject an attribute there and then trigger a vulnerability anyway. Okay. So this one doesn't work if we use if you use it in the wrong way, but we can try and sandbox functions. So we saw that by mixing syntaxes, we were able to call the alert function, so we can try and sandbox it. So alert is a function on the window object in a browser, and we can try to call it from something else, for example, from Angular. So Angular has a templating engine, which is from Mustache. It's called Mustache. I don't exactly remember the name, but we can create templates by using double curly brackets, and then we can put the operation that has to be evaluated and displayed on the page inside double curly brackets. So if we try and do that, so we can echo from HTML special chars, it gets sanitized and yada yada, and double curly brackets aren't sanitized, so we can output something like that. But if we do that, the alert function isn't triggered inside the Angular templates. Why? Because the Angular 1.0, but every Angular version we can find has a built-in sandbox. And in this case, a sandbox means the alert function isn't called on the window object from the browser, but it's called from an internal object, which is fn. And so we can try and trigger the function from fn, but it simply doesn't exist. So if we can try to put alert in there, we have fn alert, and it doesn't exist, it goes undefined, and it doesn't work. And that's fine, but we can try and bypass it. So we don't have the function, but we have JavaScript, which is a weird word. And by using JavaScript, we can try and recreate functions. So this one is a little tricky, but it's quite simple on Angular 1.0. It is still possible on different versions of Angular up to 1.5.8 with this method, but the payload is much more complicated, and so we can. Okay, we can try and do this. The first thing we can try and do is call the constructor function on the fn object. So by calling the constructor function on the fn object, we call the object constructor. Okay, so it's like calling a new object and object constructor. Then we can try and call the constructor function on the fn constructor. So we can call the constructor function on the object constructor. Okay, it gets a little tangled up, but we eventually have the function constructor, which is the most powerful constructor we have in JavaScript. So if we can manage to call the function constructor, we can pass the constructor a string, which becomes the body of the function that we created. Right? So it's a little tangled up. But then we can immediately call the function. So we can immediately invoke the function by double parentheses, right? So this way we actually called the alert function again from the window object, right? So we have, okay, I can manage. Okay, so we can try another thing. So alert is not only a simple function on JavaScript, but it's a native function. If we try and display it on the console, we see that the body of the alert function says native code in square brackets. So if we remove the handler to the native function, there's no way we can rebuild the native function. So there's a new technique which is called malvertising, which is a portmanteau of malware advertising. I don't know if you ever saw it. So basically, ad services try and embed malware in your ads. So if you display an ad on your phone or an ad on your PC, it tries to trick you in downloading a payload or performing some action on another website or something like that. Okay, so the idea is if a malware is loaded in my page, for example, I'm using an iframe or something like that, and it tries to invoke a function like alert, I can just remove the function before I load the ad. So the ad has no way of calling the native function. So basically I just do something like window alert equals undefined. So the function doesn't exist anymore. It's like from before from the fn object. So we can load the ad. The ad tries to invoke the window alert function and can't find it and can't load it. So the alert function, of course, is an example. We have other functions, but we can try and block all the functions just to not to let the malware exploit them. The problem is functions can't be created, but every time a DOM is created, document object model is created, we have a new document object model, and functions are created from scratch. Not exactly from scratch, but we have the new function again, so we can try and create a new iframe. So a loaded add can try and create a new iframe inside his iframe. So it's getting tangled up again. So we can create an iframe inside the iframe. Then try and fetch. So we can fetch the window object from inside the iframe, and then use it and put it in the window, the parent window alert function. So we basically reset the alert parent function, and then we can invoke it again. All right. So I guess if we don't have anything, okay. If everything is clear, or if you don't feel like asking anything, so we have a bonus stage. Okay. So what happens if I put some credential on GitHub repos? So we use Git, we use GitHub, we put or GitLab if you don't want Microsoft in your repositories right now. So we use GitHub for our project. We put them in a public directory, and then we discovered that, or for example, we use GitHub private repo for our project. We put our credential in there, and then we have to make it public. So we have to remove credentials. So how can we remove our credentials from a repository? So most people just go to their credential file, for example, an YAML file with our credentials, and just remove it and create a new commit, and then push it on the repository. Okay, that's fine, but you actually just created a new commit with the diff from the previous repo state. So you can look at all repo states in git log -p, and then we can pass it the file we want our diffs from. But also we can try and exploit it by searching for remove password or remove credentials on GitHub. So if you ever tried it, we have something like 315,000 commits like this. And we just look for remove password, remove credentials, and we find the diff for that commit. And we have the file with the remove credentials on the right, and then the file with the credentials itself on the left. So don't do this. And if you do it, just for research purposes. Okay. So what's the conclusion for this presentation? There's no silver bullet in security. No one can make assumptions on security countermeasures by not looking in what the security countermeasure actually does. So just don't use security functions as black boxes. Just try and read the manual carefully. Just try and understand what the function does, and then use the right function for the right job. And we can also say that less is more. So putting two sanitization functions doesn't make our application more secure. Or if it does, it makes it less secure, because we can try and make them interact by and letting us bypass that security measures. So the other thing is keep questioning and keep training. We have a page on, this is our page, our training page for the Zenak CTF team. So thank you. Thank you very much for your attention. So if you have any questions. Okay. Cool. Oh. Tu cuoque.
Okay, I'm curious about one thing. Perhaps I missed it, but I didn't get how you come out with a cyber exercise. So you showed us a list of vulnerabilities that one might want to include in CTF as
Yes.
an exploit or vulnerability that you
So
want
which
to
one?
include.
So
what is the way you use? What are the channels that you use to keep you up to date with new vulnerabilities and to have hints about what are the interesting vulnerabilities that you might want to have in these exercises?
Okay, this is a nice question, and okay, there are many contact points between the security professional world and the CTF world, but they are not exactly the same. So if you want real world vulnerability, you can go on CVA, so Common Vulnerability Exploit, yes. Or you can also go on other websites or security blogs, and you can see how real world vulnerabilities on real software work. But then you have CTFs, which are real world events. So, for example, if you have every 2 weeks you have a CTF in the weekend, you can participate. And you have a digest of those security vulnerabilities, or just something like a puzzle, which is based on security vulnerabilities, which is a real security vulnerability, or which may be just a simple puzzle, just a security-related puzzle.
Correct me if I'm wrong. Is it true that to organize a good CTF, you need a lot of zero-day vulnerabilities?
Not exactly 0 days. You can have for known vulnerabilities, but you have to mix the exact payload. So we have, for example, we have a payload here. So this payload works for this. So I wrote Chrome XSS Auditor, but this is the Chrome 58 XSS Auditor. I don't know if it works exactly the same on Chrome 59 Auditor. So I don't know if it works on each version of the Chrome XSS Auditor. It might need some fine-tuning. And CTFs are usually about fine-tuning real-world stuff. So they're basically saying, the gist of this challenge is this vulnerability that we found on WordPress, but then it's fine-tuned to the specific CTF. So it's a constant work of fine-tuning payloads. Okay? Yes?
I have a question about the exploited flow.
Okay.
The object constructor.
So you have a specific slide. So do you mean
the constructor?
Oh, the Angular one? Yes. Okay, this one. Okay.
I'm not sure that I understood that.
Okay.
Well, you were saying that here the problem that you can construct a function and apply the function. So
yes, exactly. So if I can show it on our browser, maybe it's more clear on that.
So let
okay.
me see if I
yeah, sorry.
The idea is that you can construct a function on the fly and you can apply the function to and generate the alert message, right? So to bypass the
yes.
the
Okay.
box of the
Okay. So this is a little tangled up because I used native function on the browser, so it doesn't. This one doesn't work if we don't have the window alert function. But this payload let us reach the window alert function, which wouldn't be available from inside the sandbox. So it's more of a red pill. It's more of a sandbox escaping technique more than creating a function from scratch. You can also create functions from scratch, but usually it's not as useful as trying to reach functions outside of the sandbox. So this one is for calling a function outside the function.
You reach a function outside the sandbox, but you don't redefine the function. Right?
No, you just call it. So we just call a function which calls the alert function on the window object.
And is it possible to redefine a function that is
It is possible to redefine a function. We can also redefine functions with native code. There are functions which can be redefined in Chrome. Okay, this is some of that fine-tuning stuff.
Because you say that if you have a native.
Yeah, exactly. But the problem is we can't recreate a native function, but we can redefine it. So we can overwrite the alert function with another custom function, which, for example, just displays some string on our console. This is fine. We can do that, but we can't rebuild a native function from scratch.
Yeah, but then you can bypass the second defense, right?
So this one. You mean this one? Okay. The problem is not the problem. The feature is okay. The feature is the alert function, which is native code. All the native code functions are calling native browser APIs. They are calling the APIs from inside for example, the V8 engine. So we call functions from inside the engine. We can't rebuild them inside our JavaScript code from scratch, but we can reassign the handlers to those functions. So we have a window alert function, which is a handler to the native API from the engine. We can redefine it by using another function, but we can't recreate the native API from scratch from inside JavaScript. So it's a little tangled up. I know. Sorry. Okay. Do you have any other question? Okay. Thank you very much.